Hi again. Here is a second video about normally distributed data models. It's what you can do with normally distributed data. And again, I'm doing this demonstration with the homework packet for spring break, as promised, this time with question B. And it's a real life example of how you might apply this following idea. How to calculate values from a given probability or a given proportion. So, just some quick notes before starting. This all is a picture of the first page of the packet that is part of spring break homework. You can get the packet by going to our MyRCC page, our MyRCC coursework page, and the homework 9 and 10. I go to the homework 9 and 10, and I go down to the bottom of the page. The packet picture you saw is from this packet, Practice Normal Distribution Probabilities. When I click on it, you can see it's a 4-page packet, and here is the first question. So I'm going to be talking about question 1b, how do you find values from a given probability portion. And last but not least, I will be using this software to write notes for this video, so we'll have to ignore the black bars around the edge as much as possible. But I encourage you to pause the video now and open the document so you can read along. And all right, so here we're looking at question 1b, and again, it's a different type of question, not about finding a probability based on a given baby weight, not about finding a probability. And hopefully this will be clear as we read the question. So I'm going to read the question, and I'm underlining, highlighting details. The University of Maryland Medical Center considers low birth weights to be those that are less than 5.5 pounds. This data suggests that birth weights are normally distributed with a mean of 3,152 grams and a standard deviation, also given like this, 693.4 grams. Now part B asks the question, find the weights that are considered to be significantly low, whatever significantly low means. Oh, and here they say, using the criteria of a birth weight that is significantly low is a birth weight that has a 5% chance or less of happening. 5% chance or less that if we picked a baby at random, that the baby would have that low of a birth weight. And because we're told that we're interested in the 5% of the babies with the lowest birth weights, this question is different than before. Right? Before we were given something, let's say, before we were given something where, oh, here I have some sort of value that I'm given, what proportion of the babies would have a weight lower than that or above that, for example. But this time we're told, hey, what if you're dealing with the lowest 5%? What if we know that this area here is 5%? Well, what if I know this area is 5%? Those types of babies, well then what is the criteria? What is the cutoff weight for 5% birth weight babies? So, here are the steps. Here are the steps for finding a value, a percentile, if you will. You can call it a percentile. Here are the steps for finding a number, like this question mark, given a percentage, given this percentage here. So, let's see. Given a percentage. Steps for finding this question mark. What is the value, the birth weight associated with getting a 5% chance less of having that baby? The percentages, probabilities are areas under the normal curve. Great. This is what we're going to be able to do, is figure out that birth weight. And the steps start off the same as before. Drawing the curve and labeling the points. Why do I pause? It's because we should all take a minute and draw that curve. I started here, and we should probably make sure that I've filled in these red lines as well, because this is where you'd have the standard deviation shown. We have a normal distribution with this mean and this standard deviation. Okay, I've drawn the mean here, but how do I demonstrate the standard deviation? What's the lowest and the highest usual baby birth weights? So why don't we take a minute now and fill in this picture. Take a minute now and fill in all 7 of these points along a curve. And if you finish that, you can try shading the area. Okay. So if you've had a chance, you can also pause the video some more. Step 1 for finding this number is to draw a curve, label the points, and I've done that here. So I've only done the low levels because we're finding the probability of 5% or less. In other words, and I can draw, now that I've drawn the curve and labeled the points, I can shade the area that I'm interested in. The area that I'm interested in here, is the area that's about 5% of all the area. 5% of all the area in this curve. It's something like this. But it's hard to know for sure, because I don't know what number along this line, 3,000, 2,000, 1,000, I don't know which number corresponds to 5%. So I'm making a very rough estimate, kind of shading in some area, but it's important I shade something so in my own mind I acknowledge that I'm interested in shading an area or less, something to the left of whatever number I'm trying to find. That's kind of something like that. Where is this number that I'm trying to find along this number line? Alright, so step 1, draw the curve, label the points. Step 2, shade that area of interest. Done that also. And step 3 is to find the value. When I say finding the value, finding that space, what I had there, that question mark, finding this value. Finding the value that you're interested in. If you're lucky, you can use the 90, 68, 95 rule. We're not always lucky. If you want to use the normal table, there is instructions how to do it on page 208 in the textbook. I'm going to choose to use technology because personally I find it easiest, and I don't carry around the normal table with me. So to find this number, I'm going to use personally technology, and the technology that I'm going to use is you can see it's still by Online Statbook. Online Statbook, instead of just a normal distribution calculator, we used a normal distribution calculator for part A. Here there is something called the inverse normal distribution calculator that we'll be using. So I've drawn the curve, I've labeled the points, I've shaded the area of interest, and I'm going to use technology. And the technology I'm going to use is called the inverse normal distribution calculator. There are many versions online, but the one that's used by, or created, but the inverse normal distribution calculator created by Online Statbook, I find to be one of the easiest ones to use. So I'm going to go to my internet browser. I encourage everybody to do the same. I encourage you to all open an internet window. Again, I'm going to open a Google window, and I'm just going to start typing inverse normal distribution calculator. When I click that, the first link, the first link to appear, is the one made by Online Statbook. You can see there are other versions of online inverse normal distribution calculators. We'll use this one. So I click on it, and what opens up is something that looks a lot like the normal distribution calculator from Part A, from used in class, but this time it says the words inverse normal distribution calculator. Inverse normal distribution calculator. So it has, again, a picture and places where you can input things. And the steps, the instructions are here on the right side. It says, first, specify the area, the mean, and the standard deviation. Each time you change a value, after changing a value, you hit enter. So I've got to specify, and I see here, area, mean, standard deviation. I see down here, area, mean, standard deviation. These are the three things I need to specify. Now I know what the mean is. I'm given what the mean is. I'm told that the mean, go back to the problem, I'm told that the mean here is 3,152. 3,152 grams. I'm also told the standard deviation was 693.4 grams. Can always go back and check that, 693.4. Great, I got it right. But it's also asking me for this area, this first thing. What area do I want? Well, that's the percentage they gave us. Again, because areas under the normal curves represent percentages. Areas under the normal curve represent percentages of all of the area that's inside this bell shape. If someone tells us that there's 5% in this area, that means that 5% of all the data is in this shaded space. So I'm told that the area under the normal curve is 5% here. And I'm going to go back to this online calculator, and I'm going to input that number into this space where it says area. I'm going to input in here the number that represents 5%. However, and this is the most important part, easiest place to make a mistake, the first thing you have to do is you have to change that percentage into a decimal. That has to be done if you want to use this inverse calculator. I'm pretty sure if you use any inverse calculator, you have to input numbers as percentages, input percentages as decimals, not as percentages. So if we want to use the number 5%, which we do now, if we want to use 5% to represent the area of interest, we have to make sure to input not 5%, we have to input 0.05, 5% as a decimal. Once I do that in my calculator, you'll see that the graph changes even more, not just the distribution, markers. When I specify 0.05, now I can see here is some area that's relevant, somewhat similar to the shape that I had. I can go back, I can look at the shape, and I see, 5%. It's kind of similar. It's a kind of similar shape. Unfortunately, it's on the wrong side, isn't it? Over here, this is in the wrong side. We want it to be 5% or less probability. 5%, it's the 5% on the left side. So when I'm using the inverse normal calculator, once I tell the calculator, hey, I'm interested in a 5% area on this distribution, on the distribution with this mean and this standard deviation, you also have to tell the calculator, hey, I want to know the area when it's below a certain number, or I want to know, using the area between two different numbers, what are the values? Now for here, I know that I want the area, I should be selecting this button below, shouldn't I? I should be talking about the area, 5% area that is below some unknown value that I'm trying to find. And I'm gesturing right here I'm gesturing right here because that's kind of where it seems like 5% is. If I took this image and I flipped it over this way, here's about where 5% is. But what exactly is that number? Oh, I won't know until I click below. And then the number appears right here as the picture jumps to the correct spot. It says below, and the number I get is 2011. Let's zoom in a little bit so you can see that better. Zoom in a little bit, maybe. Zoom. There we go. So I've shaded, there we go. So I've shaded on this inverse normal distribution by inputting area, clicking below, and using these numbers. I am told 2011.458. 2011, this number right in here, this number separates out 5% of the area down here and 95% of the area up here in this white space. Below, this is the only, there's no other answer box down here because this is the answer. Again, we are looking for some number along this number line that will split out the lowest 5%. And here is that answer. I go back to the question page. If I look at it, it's asking us, find the weights or the weights considered to be significantly low when the criteria of a low birth weight is the probability of 5% or less. So 5% in here, and then ultimately I get this answer that hey, it's when babies weigh less than 2011.458 grams, 2011.46 grams, that's the marker below which you'll see 5% of the babies. There's a 5% chance of all babies having this birth weight or lower. So, we've just found the value, found the number that separates out that lowest 5% probability. So, we have answered steps 1, 2, and 3. Find the value using this rule. Cross that off. And the last thing is, and again, the most important thing, is to interpret your answer in context. So even if I got a number, which is great, once you have a number, then you also have to explain what number you're talking about. So, oh dear. Sorry. So once you get a number, you also have to explain what that number is. So here's a way I thought to explain it. Babies who weigh less than 2011 grams, those are the babies considered to have significantly low birth weights. Significantly low birth weights. So in this question, just to summarize, in this question, part B, when they're asking, find the birth weights considered to be significantly low for babies that generally are normally distributed with this mean and this standard deviation. For babies that are distributed with this mean and this standard deviation, what birth weight would separate out the lowest 5% of the babies? What birth weight would separate out the lowest 5% of babies when we know that all babies weigh, on average, 3,100 and standard deviation of 693? What weight will separate out the lowest 5% of the babies? Well, 2011. Babies who weigh less than 2011 grams. Those are the babies considered to have significantly low birth weight. So draw the curve, shade the area that you're interested in, and then find that actual number, that 2011, using technology. And last but not least, interpret your answer in context. So important. And using this technology piece, again, I opened an internet browser and I typed in inverse normal distribution calculator. which you can use in many different ways. Inverse normal distribution calculator, there are many different versions, but this one, when I click on it, gives me a picture as well. So I like pictures. They match up with the pictures that I drew on paper and are a good way to double check that you're not making mistakes. So I specify my mean, I specify my standard deviation, I make sure that I specify my area as a decimal, 5%, 0.05, and then I have to select the circle. I select the circle that is showing the area below. And then your answer will be in here. Your answer will be in here. Below, when I've selected a mean and a standard deviation, below, with 5% of the babies, that's separated out with 2011. So those are the steps. This is one online calculator. And we've come up with an answer for this question. And please don't hesitate to reach out if you have more questions. Thank you for your time.